All right. The final exam scores of a statistics class were normally distributed with a mean of 63 and a standard deviation of 5. Let's go ahead and note, remember the mean is our mu, that's 63. The standard deviation is our sigma, that's 5. And let's also write what this distribution is. Okay, remember practicing that notation. Our random variable is distributed how? It is normally distributed with a mean of 63. That's the first key value, and a standard deviation of 5. You should be practicing this as you go. All right. Find the probability a randomly selected student scored more than 65 on the exam. So be sure to write the probability question mathematically. I've been trying to emphasize that as well. Okay, make sure we are writing that. P of what? Randomly selected student scores more than 65. So our random variable or our selected student scores more than 65, strictly greater than 65. All right. Now, remember, if you can calculate it by hand using the empirical rule, you need to. All right. But for these specific values, that empirical rule, 63, 1, 2, 3, 1, 2, 3. So 63 plus 5 is 68, plus 5 is 73, plus 5 is 78. 63 minus 5 is 58, minus 5 is 53, minus 5 is 48. All right, that would be my normal distribution. 65 is not a value that's directly on there. This is not one that we can approximate using the empirical rule. All right, so if I was to ask this on a test, again, assuming we can't get a computer lab for our next exam, all I could ask you to do for this is to set up the question, which we just did, and to sketch the region that would be corresponding to this probability. All right, meaning that if this is my normal curve, where the mean is 63, that's in the middle, right? We should always mark our mean, draw our curve. 65 is something bigger, okay? And if I was asking you to sketch this, I wouldn't expect it to be perfect. Sure, you can write out the 3 on each side to double check that we can't use the empirical rule. But past that, we have 65 marked, and we want the values to be more than 65. We are looking for this area over here, more than 65. All right, and I'm drawing this one because, again, if we don't have a computer lab on the exam, this is a way where I can make sure that you understand what you would be looking for on that calculator. All right, because the normal distribution calculator I'm going to show you here in a second will have this picture. All right. So let's go ahead. Let's go ahead and show you that. Okay, I'm going to go to our Canvas shell. I'm going to go to the normal distribution calculator. So notice that I added that to our text and calculators. Okay, and I'm going to open up in the new web browser what this is. Okay, we are working on this picture here. Now there are these toggles below. That's what I'm calling these little like parenthesis looking things. And notice as I click the different ones, it adjusts the picture and changes where it's shaded. All right, it also changes the statement at the bottom, P of, all right, in our parentheses. Here, X is greater than 65 for us. Notice that it says P of -1 is less than or equal to X. All right, it does move that around, but the alligator mouth is still opening towards X. X is greater than -1. Okay, so don't mind that it shows it a little bit backwards. The picture looks like how we want it to look. We just need to adjust our values. Okay, we have to fill in our mean. Our mean was 63. We have to fill in our standard deviation. Our standard deviation was 5. And then we have to go and we have to fill in the value we are comparing X to. We are comparing X to 65. So as soon as I type that in, all right, if I get out of here, oh, why isn't it? There it goes. It shows the picture just how I had it, shaded to the right, and it shows this corresponding probability of 0.3446. That is our solution here. All right, that's how the calculator works. This probability is equal to 0.3446. 0.446. That's how we're going to do these. Again, when you cannot approximate using empirical rule, you resort by going to that online calculator. But I want to emphasize that you should be practicing writing the statement mathematically and drawing your picture, because if I was to put something like this on the test, that's what I could ask you to do by hand, since we are not using our, I didn't require the class to go ahead and rent or buy those TI-84s, okay? So we're using these free online calculators that you can access in your future. All right, so let's look at the next one. Find the probability that a randomly selected student scores less than 70. I challenge you, now that we just did that first one, to try these next couple, pause, and then join me. All right, so P of randomly selected student scoring less than 70. Let's draw it. Again, just for my sketch, I don't care that you are that accurate. We can go double check that number line I put up here. 70 is not a value we can use empirical rule for. It wasn't on there, okay? So we have to use the online calculator. I do care that you mark where the mean is, so at least the value is on the correct side of the mean, okay? I shouldn't be marking 70 over here because the mean was 63. All right, we're marking 70 and we want the values to be less than 70. So I am shading to the left of 70. Oop, got a little off there, that's okay. This area is equal to that probability. All right, let's go to our online calculator to see what that is. I don't want it to be shaded on the right anymore. Now I want it to be shaded on the left. So again, I'm right below the word normal here. That's where I'm clicking to see the different types of how it's being shaded. So I want it to be shaded on the left. We still have a mean of 63. We still have a standard deviation of 5. I want it to be shaded on the left, and I want to be comparing the value not to 58. Filled that in. I want to say X is less than, and here it says less than or equal to, but again, that is the same thing in the continuous world, less than 70. So as soon as I put that in, the picture has 70 marked, shaded to the left, and it auto-populated that probability there of 0.9192. 0.9192. All right, as you write these, make the little markers. Hey, we clicked on this toggle here. It looks a little like that. We clicked on this toggle here. It looks a little like that. All right, and how we're filling those values in, if that helps you when you go to do this on your own when you're working on that homework. All right, and now we have our between situation. The probability that a randomly selected student scored between 52 and 67 points. 52 and 67. All right, I can check. 67, no. 52, no. I can't use the empirical rule. Okay, I have to use my online calculator. Mark where the mean is. 63 in the middle there. All right, 52 is somewhere to the left. 67 is somewhere to the right. And we want to be between these values. So the area between these values is what my probability will equal. All right, going to that online calculator. Again, same mean, same standard deviation, so I don't need to change that. As I go to these little button options, I want the between. So this is the one that has the 2 brackets with the shading in between. And I want it to be between 52 to, and you notice when the between happened, there's 2 blanks inside my parentheses here, all right? 52 to 67. As soon as I type that in, my picture updates. You see 52, somewhere between 50 and 55, 67, just above 65, but before 70. All right, and says the probability is 0.7742. I can't emphasize enough that you need to be practicing drawing the picture and writing this probability statement, because if I don't ask for an empirical rule question, I can ask for these things and then, just assume that you knew how to use the calculator correctly past that. Okay, if you have any questions about this, please, please, please come to office hours, ask me about it. We are going to do another example or two, as well as some other pieces. Okay, chapter 6 is a very, very important chapter.